Okay, we're going to get started again. Hopefully you had a good lunch and all set for some more presentations. I guess we just got to get the the presentation screen on, or maybe that's here. But anyways, in the meantime, I'll just go ahead and we're going to have 4 entrepreneurs that went through the Zen Launchpad program. We're going to have Abel Losario in a minute here, Majid Mohammadi, and Dinakar Sackville, and then Eric Martinez. And then once we've had those 4, then we're going to have Dr. Abhay Gatpande talk a little bit about what do investors look for in startups, especially ones that relate to AI or computing and things like that. So we've got some exciting startups, and I'm going to pass it over to Abel. Let's give Abel a hand. Thank you.
This is your website. Yeah, no worries. Okay, so hi again. So my presentation is a little bit about a practical use of AI and data to feed that AI is not as technical as the previous talks. So yeah, it's more of a practical use case. So to give you a little bit of context about Nubel, the hiring industry, we found that is fundamentally broken. This means that there are several companies looking for candidates and also several people looking for jobs. And for some reason, they seem to not finding each other. We have a lot of cases where, especially here in Vancouver with a lot of immigrants, you have people with PhDs or 15 years of experience in some field, and they spend like 5-7 months looking for a job. Actually, yesterday I was in an event, and there was a study from British Columbia showing that the average time for a person to get a job here is 7 months. So that's crazy because you have all these other companies saying, hey, we need people, and we can't find people. Where those are the people you need. So what's happening, right? So after a lot of research, we found that the systems and processes that we are using to match companies to talent are systems and processes designed for a different age, basically. So for instance, the interview process was something that was popularized in 1920 by Thomas Edison, just to interview fewer people for him. And after interviewing those, tens of people, he got a process to filter people and eventually hire one. So he popularized the same hiring process that we are using now. And also the resume, which is the main piece of information that we use. The first version of it was written by Leonardo da Vinci, like many years ago. And the modern version, the same version that we are using now with education, work experience, like the same format that we are using now, was popularized during the World War II. Also a long time ago, industrial age, no digital information systems, different world. But the crazy thing is that we are still using those systems, those same processes. If you look at a LinkedIn profile, is just a digital representation of the same 2-page document of the 19th century. So that's the context of our work. And our approach is, okay, how can we help recruiters and companies get more information before the first interview so that they can make smarter decisions, hiring decisions? Also, another problem here is that because of the lack of information before the first interview, companies are making very fast decisions. Actually, the results of a study that says that recruiters spend 4 to 6 seconds before saying no to a profile. They only look at the profile picture and the headline, so they make a hiring decision in 4 seconds. The consequence of that is that they have to, for each job posting, they receive like 200 applicants and more. So they have to do, they have to decide very quickly who to interview, who not to interview, and maybe, the people that they discard are actually the people that they need, but they will never know. So our approach, as I said, is try to get them more data before the first interview, and that's a really big challenge. So first of all, where do we get that data from? The word data is, in this context, how can I phrase this? The crazy thing about this approach is that the data is not something new to the process. Data is collected through the process, but is not stored in a way that can be shared. So, for example, the interviews are generally meant to collect information from candidates, and all that information gets lost. So whenever a recruiter asks a question and gets an answer for that question, that answer gets lost unless the recruiter writes it down somewhere. And even if the recruiter writes that question down, most likely that information will be kept within that company and won't share with any other company. So that's a piece of information that gets lost during the process. But the information is there, the data is there. Other pieces of information that are collected during the process are job references, performance data, different type of assessments. Well, there is a lot of data out there. So our approach is try to collect all that data in a single place. And also once we have enough data, we can later feed an AI to execute different actions on that data set. A very simple use case of that is the more data you have, the more specific you can be on searching candidates. So now instead of, if you guys ever used LinkedIn Recruiter, you search by using Booleans. So in this case, instead of using Booleans, you can be as specific as, I need a full stack engineer that knows how to code React and Node, and that had experience in this field and work with small teams, or in this kind of scenario. You can be very, very specific. And the result of that is that you won't have to interview 200 people, you may have to interview only 10, because the results of your search is way more specific, because the data behind the search is more complete and accurate. For the context of this event, I want to make a point in the use of AI. I've seen so many companies trying to use AI on just resumes or that kind of information. And the problem with it is that if you don't have enough information, or if the information is not reliable enough, no matter how cool the AI you use is, it would be useless, sorry, because the source of data for that AI is, incomplete, inaccurate. So what we are trying to do here is, before trying to do something really cool, really ChatGPT-like, is, okay, let's collect the data first. Let's make sure that that data is reliable enough, is complete enough, and then, of course, we can integrate whatever tool we wanted. That's our website. You can check it out. We have launched our first version of this during August, actually on August 14th. We have about 150 people signed in. We are targeting first tech immigrants in BC, and also companies in BC that are looking to hire people in tech, or immigrants in tech to be more precise. Yeah, I think I will stop there and answer any questions.
Okay, any quick questions? We're going to have a panel a little bit later with all the speakers, but maybe just a quick question.
I got a question. My question is, since you're doing a lot of filtering and all those samples, right? So today, traditional resume saying I've done this beautiful and everything, does that still matter in terms of using your system to publish?
Your question is whether optimizing a resume.
For example, let's say I'm helping company A, I've done A, B, C, D, I have B to make a software that was $350 million,
Yeah.
that kind of stuff. So instead of writing that, I say, I know React, I know this, I know that, which you'll be able to discuss.
Yeah.
So which one is a better way to write a resume that is easier?
That's a great point. So we are all tech people here, and we understand the data has different processes. One of it is collecting the data, submitting the data, and a different process is how the visualization of that data. Another problem of the resume is that it is only one. You cannot take the visualization out of the format because you see what you get what you see, right? So what also we are experimenting with here is submitting data is one thing, and how you want to see that data is a different thing. So maybe you as a candidate or even as an employer may want to focus more on the achievements of a person instead of the skills. Or maybe you want to focus more on the soft skills instead of the hard skills. So, and this is a great example. We are experimenting on how the skills are displayed on the screen, and you can actually change how that chart looks like. So to answer your question simpler, we've been focusing so far on trying to convince an employer of with our resumes, and it's become more a marketing tool as, for ourselves than actually like a data repository. We want to change that, and we want to have the data repository, and then separated from that, whatever presentation form we wanted to have. I don't know if that answers your question. Yeah.
Okay, thanks a lot, Abel.
Yeah.
I'll keep it at that for now. Majid. Next up, we have Majid Mohammadi, and he is doing some interesting things as well with some high computing and company smartteeth.ai.
Thank you very much. Hello, everyone. I'm not talking about my startup. As I told you, we are a tech company, and one of our first product in health industry is Smarties. Smarties, like the name is for your AI mouse mirror that can identify the health problem in your mouse. So this is our team, generally background in AI, machine learning, and business. So what's the problem in this industry? First of all insurance deal with frauds. Sometimes they have some treatment that is not necessary for people. For the people, they spend a lot, sometimes unnecessary, sometimes too late, and like that, government deal with the untreatment caries, and the dentists have the diagnostic challenges, and for the social burden, we have too much loss about the productivity or sometimes over treatment. So this is the problem that we deal with. So the product that we have is AI-powered product that you can see at the first things that is normal for patient. First of all, we can advise for the patient that visit the dentist, for example, what is the problem, what is the guess for the number of the caries or cavities or root problem, as you can see here. And after that, sometimes general advice like brush your teeth more and something like that. This is from the patient. So we have some RGB based. We have two type of images. First of all, was like this. This is X-ray. Maybe you are familiar with that. And this is the second one that can be captured by like your phone or a special camera that we have. The accuracy for this type is less, but still works, and a good guess to send you to the doctor. This is the profile that we create for the caries. And yeah, this is the helps that we prepare for the patient, schedule and plan for the treatment, estimate staying length and cost of treatment. This is the other option that we can prepare for the patient. The things that we do is segmenting all the teeth, and for each teeth we have preparing the treatment plan. Oh, that's okay. The more concern about the insurance is about the dental procedure. Sometimes change the identity. For example, the dentist, dental clinics send the same image for the patients, and this is kind of fraud that insurance deal with that. And unperformed procedure. This is also the other type of fraud that is very important, and it's billions of dollars for them to deal with and finding the fraud. So one of the customers is one of our customers is insurances. So this is all type of the frauds. Like you can change the identity, change the OPG, sending the same OPG for the same patient, and you can find all of this by the algorithm. So insurances, yeah. When we are talking about the clinics, first of all, it speeds up the procedure. Its efficiency when the dentist come to the room, everything is detected, and this is kind of AI assist for the doctor, and it's reduce the workflow for it's getting better for in case of the accuracy, and also patient satisfaction. It means that we educate the patient what happened to you, what's the treatment plan for you, and like that. And in dental clinics, we can find where is the caries or cavities exactly, like here or here, and for the doctor, we can recommend the way that can treat, and also all the teeth that, as you can see here, is segmented one by one and report in the screen for the dentist. This is the SaaS, software as a service. We can customize the software as our client need, like integration with the third-party application that already they have. We can add some feature as they need and like that. About the cost reduction, it's obvious. So if we treat less, the cost is gonna decrease. About the public education, this is one of the things that we prepare about our app after treatment. Yeah, the product feature right now is like this: caries, cavities, restoration, and also recommends dental health and information about the urgency and some general tips like brush your teeth more or something like that. Yeah, that's it. Thank you.
Okay, any questions for Majid? Do you want to say a little bit about sort of the technical architecture behind the things you're doing? Because I think you're doing some high performance computing in the background. Do you want to talk about that? Or?
Actually, the first stage was about algorithm development in the tech team. Actually, we are not AI-enabled company. We developed AI algorithm for the special image processing algorithm. Like first of all, it's in dentistry area, and second product is in MRI. We are developing MRI also. The algorithm that we use is, it's specific in the specific area. But after developing that, we use NVIDIA and general GPUs to train our model. Yeah, and after that, we go for the, increasing the amount of data to make it more validate and more accurate. Yeah.
Oh, did I miss a question? Okay.
Just a quick question, because I just gave a little bit late. I'm wondering in terms of when you take a picture of your teeth and the cavities, that just came a little bit late, so I'm just interested in that part.
Okay, we'll have to leave it there. Thanks very much, Majid. Let's give him a hand. Okay, I think Eric Martinez. Why don't we go with Eric and then Dinakar? We got two quick presentations, and then we've got Dr. Abhay Gapande, who's going to be talking about what does an investor look for. Oh, sure.
Thanks so much. Yeah. Hi, nice to meet you. I am Eric. I have a 3D printing company just here on the North Shore that is called Upsurge 3D. What we do is industrial 3D printing, and we serve a variety of industries ranging from oil and mining, automotive, medical devices. That is our website. We just recently launched the company. Well, not recently, but we've been in business for 1 year. And the way we operate is 70% our business comes from e-commerce. So the customers can upload the parts into our instant quoting software. There they get an instant price. They can see the properties of the parts, choose the material, like the delivery time, and any other finishes like post-processing. Once our customer wants to check out, they can pay online, and then we receive the order. Everything, it's cloud-based, so we can check all of those files on our app. So it's very easy to handle. When the customer checkouts, he will receive an email confirmation, as we usually do when we purchase from Amazon or any other site. And then is when everything starts to happen to us. We have an order management system where we can track the orders. But our printer is quite peculiar, so because we can print many different parts at the same time from different customers or even from the same customer. So it's very complicated without using softwares like this to handle all of those files and manage to deliver those parts on time, but also with all of the right quantities in place. At the beginning, we didn't have these softwares because it takes a while to put them live. And we made a few mistakes, even with small batches of products, because some of the parts can be very similar. So when we were trying to put them all in their boxes and pack it, we didn't know which part was the right one. So right now, with this system, we can operate in a more efficient way, in a faster way, and now we have a pretty much 99% of accuracy when we deliver. What happens with of the printers we have is an HP printer, the one we have, and all of the printers from HP are connected all over the world. So HP can track our printer and see how many parts we have printed in one day, how many days a week we have operated our machine. If our machine needs to be fixed, so there's a lot of preventative maintenance ahead of having before our printer goes down. For example, I think it was 2 weeks ago, one of the parts of our machine break, and HP immediately sent us an email saying that our machine needed to be fixed. So they knew what was going on with the printer. They shipped the parts, and then they flew the technician from the US here, and it took 2 days to bring our machine back to work. And I know that maybe this doesn't sound like very impressive, but with the machinery that I used to have back in my country, in Mexico, we have injection molding machines back there. When our machines break, then we have to first figure out what's wrong, call the technician, figure out what's wrong, then order the parts, and then call the technician again to fix that machine, to fix the machine. And even if they detected what was the issue, we weren't completely sure that was going to be, that maybe some other parts were broken or not. Other things that we can foresee with HP services, so we can track the prints that are being in place. So if there's something wrong with their printer at that time, we can stop the print and then go back and reprint those parts. So that's really good for us because we have a lot of traceability, and our customers ask for that. If they want to reorder a part, we actually know how to reprint those parts and have the parts printed in the same way. HP can improve the quality of our prints due to a system they have, a machine learning software they have in place. So every time we print a part, they can see how accurate it was compared to the file they sent over, the customer sent, and they can keep improving the parts. They actually don't get to see the actual parts, they just see dimensions and accuracy, and that's to protect the data from our customers. Well, going back to what we actually do in the company, once we receive the orders, we track everything, order management system, payments. We can track our accounting is in place, so we don't have to do any invoices. So we handle all of our operations only with 2 persons, plus 1 operator and 1 designer, but the company actually runs with 2 people. We don't need to, we receive the order, we just have to do cleaning of the printer, filling the printer, put it in, and then do some post-processing. But when it comes to actually operating the accounting and everything, we have everything in place. I feel that having all of this system for me is not the right time because we have invested too much money into softwares and apps. But my idea is that to have all of this technology in place now will save me time and money in the future because I know how to use it. Otherwise, I will have to go back, train, and reconfigure everything that we're doing. Right now, we're trying to change our instant quote software to a new one that is called Facio. And we want to go that way because they have integrated some AI into their platform. So if you want a specific material for a certain application, you can just ask the system, I want a part that will withstand, I don't know, any sulfuric acids or any chemicals. The system will immediately tell you and give you a recommendation for that material. If we don't have that material in place, then we just reject the order. But if we do, we can give them a couple of options to do it. And yeah, I think that's pretty much what we do. We have 4 systems in place in our company, and that can make our life very easy. We can operate the company like from home. A lot of the things we could do, we print at night, so now that I'm going home, I'm going to print, I'm just going to send the job to print, and I can just track everything down, and then it's just a matter of cleaning the parts and shipping the parts. So it's just like the manual labor that hasn't been automated in our company, and we know it can be done, but we're not there yet. It's a lot of money to do that. Yeah.
Thanks, Eric. Okay, great, thanks. Okay, I think we'll hold the questions for the panel. We have one last person, Dinakar. Do you want to come on up? And he's got a company called Heterogeneous AI, marketing automation, and also one of the court members.
Hi everyone, I'm Dinakar Shaktivel. I'm here to present leveraging AI and cloud computing for marketing automation. Big thanks to Zen Launchpad for making this possible. Big thanks to Mr. Siri over here for taking me into the incubator program. Without that, I wouldn't be here right now, so thank you so much, Mr. Siri. So marketing automation in simple terms is the automation of repetitive marketing tasks with the use of software tools. The rise of AI in marketing is sort of fundamental to where a lot of things can change going forward in the marketing field. And I'm saying that because AI can automate a lot of manual tasks like content creation, customer segmentation, and personalization, and even simpler tasks like data analysis, for example. By automating tasks like this, valuable human time and resources can be freed up for more creative and strategic decisions in the company. I took the statistic, and the first thing that I look at it is that the content personalization is one of the most important factors when it comes to marketing automation. And I again tried to reconfirm my findings by conducting a small survey. And my survey, it was kind of like similar results from it. My survey said that data analysis is going to be a big factor when it comes to using AI for businesses, and it is followed by marketing, which is something that my startup is going to focus on initially, and later on my startup is going to focus onto data analysis itself. When it comes to the marketing, the biggest challenge is scaling content creation for bigger brands. And I'm saying that because when you're working with a big brand, dealing with consistent and high quality content, it becomes an issue. I read the statistic from Forbes, which says that 63% of marketers agree that writing consistent, high quality posts is one of the biggest issues that I've been facing recent times. And I feel like this is something that can be tackled with the use of AI. AI-powered solutions can automate content creation in ways that we haven't used before. AI can analyze data, AI can analyze content on the public internet, and it can give you a personalized set of content, a personalized draft, if you will, and that's something you can take it ahead and work for further, revise that into different versions and publish that later on. When I say content, it's not just for blog posts, it's also for social media posts, it's also for emails, it's also even for simple things like Facebook ads or even social media posts in general. I feel like some of you might be skeptical about AI. You might be like, AI could be generic, it could be inconsistent, it could still need a lot of human review, and I do agree with you guys. AI is in its early stages right now. Last year around this time, that's when AI really took off, and considering the short period of time, it has come a long way so far. What I'm saying is that AI is not perfect. It's not going to replace human talent anytime soon, but it needs a lot of human input in general to make it work for us as business people. This is where Heterogeneous AI comes in. Heterogeneous AI comes in as your content creation partner, and I mention it as your partner because it's not going to replace your existing marketing stack or your team. It's going to assist your existing marketing stack and team. Heterogeneous AI, it automates blog post writing by analyzing your existing, say you have a business website, it's going to analyze your existing business content, and it's going to use sentiment analysis algorithm to understand your brand's tone, voice, your products and services. So next time when you come into the product, next time when you come into Heterogeneous AI and, so what Heterogeneous AI does is that it has this brand voice module, and the moment you enter your brand's website, it's going to automatically understand your brand's content, and it's going to fill it out, what it understood from that. And the thing about that is that if you feel like what it understood is not perfect, you can always go in and edit it so that it can fit your business needs and requirements. Once this is set up, the next time you use the AI article wizard to ask for an article, what it does is that the first step is you give what your idea is, and then in the second step it's going to ask you for a little bit of title, and then when you click generate title, it's going to come up with a list of ideas that you can begin your work with. The third step is image generation, and the last step is the draft creation. All of this, it could be done with ChatGPT, for example, and all of this could be done without any use of AI at all. You can create it manually by yourself. But using AI for this sort of thing, it helps you speed up the process and helps you scale effectively. And I'm saying that because I used to work in this field for 4 years now, and these 4 steps are fundamentally, I feel like they can be automated. This is just the repetitive steps, coming up with a blog post title or sourcing for images or writing the first draft. I feel is the hardest part when it comes to writing. And if any of you have ever written an article or a journal, I feel like you can relate with me, because the hardest part for me when it comes to writing something is the first paragraph. The first paragraph when it comes to struggling and changing from the creative block, I feel like that's something AI can help you tackle with. Not just that, it's not gonna, like I said, it's not just gonna stop at blog articles. It's also gonna help you, say, summarizing text or creating product descriptions if you're working with e-commerce products, or say you're working with Facebook ads, for example. It's gonna help you with that as well. So anything that has to do with content, anything that has to do with even image content, that's where Heterogeneous AI can help you come up with a better workflow for your business. So before AI, it's going to be manual and time consuming. You have to write content, edit, publish, and it's going to take anywhere between a few hours to a few days from my personal experience. For me to research, come up with media and writing and publish and distribute it, it's going to take at least 8+ hours of work. But lately what I've understood is that with the use of my own platform, I was able to save up to 24 hours. And that's just for 8 documents. In 8 documents, I'm able to save 25 hours. And again, coming back to the research, media, and writing parts, by using my own software, I was able to complete an 8-hour task in less than 3 hours. And that's just personal experience. If you're working with a large team, then that is going to compound. You'll be able to save more time. You will be able to achieve operational efficiency, and that's something that Heterogeneous AI can help you get to. Why this works? It works because the content that the platform creates, it's consistent, and it follows best practices because it's built on top of ChatGPT. The quality that you're getting is the same as ChatGPT, and that means it's easier to rank because it's easier to understand and read in general terms. And the second thing is like it's going to improve the speed, like I mentioned, and it's also going to improve the scalability of your content creation and marketing needs. So take action today. If you scan this, you're gonna go to the website. So feel free to take a look and sign up for a demo. I feel like a product like this is going to help your team focus your effort on creative decisions and strategic decision making, and it has to help your team when it comes to corporate decisions and stuff like that, and repetitive tasks and things that has to take you have to take steps again and again. It can be outsourced to AI. Yeah, that's about it. Feel free to sign up for a demo, and if you want to reach out to me, I'm available at dinakar@hatrio.ai. My website is hatrio.ai, so feel free to take a look, and I'm open for questions on the floor.
Okay, thank you very much, Dinakar.
Thank you.
Any quick questions for Dinakar? Yes, in the back.
It's not included. It's part of the package.
Okay, let's give Abhay another hand. Oh, actually, one more question in the back there. Okay, so now we have Professor, not Professor, Dr. Abhay Gatbande. Starting to call everyone with a PhD a professor automatically, but in this presentation, we are going to learn about what VCs look for when funding startups. So we've seen some upcoming innovative technologies, and pass it over to someone wearing the investor hat. And by the way, Abhay also did his PhD in heterogeneous computing as well, so he has that kind of background as well.
It was a long time ago. Hello, good afternoon, everybody. Wake up. I know I've got the tail end of the session, so the coffee is waiting. I'm not going to keep you for too long. And so it's been a long time since anybody referred to me as doctor. So it feels kind of weird to be referred to as a Dr. Abhay. It's been a really long time. And I'm just going to tell you a little story. So I've been, after I completed my PhD and my postdoc, I was at McGill University in Montreal. And I kind of figured out that I did not want to continue in academia, so I started my own business. Got into consulting, started working. It was doing kind of okay. We had 3 employees, and so that was about 8 or 10 years ago. And we were doing a pretty decent business. And so we decided, okay, it's time to raise some money. We want to go and raise some money. And so we created a pitch deck, and we sent it out, okay, to people. So we sent out a pitch deck. Okay, looked pretty good. So I had 3 employees: Pierre, David, Ilya. You know, I shut down my computer, sent out the pitch decks. Yes, we are going to get venture funding. Okay, money's going to come rolling in, and we are going to have a great business. The pitch deck looked something kind of similar to this. So we thought that we could do about $20 million in business in about 5 to 7 years. We would generate about $5 million in profit take home, which is not bad, right? Taking home $5 million a year sounds like a pretty good business. We wanted to raise about $2 million, and we said, okay, we'll have a valuation about 10 million, raise about 2 million, and we should be able to make $5 million a year in about 5 years, and sounded really good to me. I closed my computer, very happy. Okay, let's go party. We are going to get, the money's going to come rolling in. And what happened? Crickets. We heard crickets. We didn't even get a response back from anyone. And we were like, what's wrong with these people? They don't understand what a great business we have. They're going to make so much money. And so that's how my journey started into venture capital, when I realized why was nobody willing to give me money, even though I had such a great business potentially. And that got me thinking. Since then, I've learned a few lessons about what it actually takes to raise money from venture capital, as venture capital. And I started on this journey of discovery to find out why and how to raise money from VCs, okay? So the thing is, there are a couple of things that we need to understand. So fundraising, actually, it's an art and it's a skill that as a founder, you have to build. You have to learn. If you want to build something really great, you're going to have to raise money from somewhere at some point in time, and you had better learn how to do it. So to understand that why is it that only 1% of companies ever raise money from venture capital? If 100 companies are founded, only 1%, one of 100 companies is actually going to raise any money ever, okay, from venture capitalism. So it's an interesting thing. I have a researcher's brain, even though I didn't want to be in academia, and I was so curious. I want to get down to the bottom of this. Why and how does this thing work? So I started learning about it, okay? So the thing was, you have to understand certain realities of venture capital. Okay, venture capital, and today I'm talking specifically only about venture capital. There are other different ways in which you can raise money, but I'm talking about a very specific, what is called as an asset class. It is called venture capital. Venture capital is a very specific asset class that works on a very strange business model, okay? And I will tell you about it and why that is the case, that very few people actually end up raising venture capital. The first thing to understand is these are some of the realities. So a venture capital fund actually, so for example, I'm now part of this fund called Sprout Fund. We have a venture fund has a defined timeline, okay? It's a 10-year timeline usually. Most of the times, I would say almost 95% of venture funds have a 10-year lifetime. Some funds nowadays are going up to 12 years, but it's very, very rare, okay? 10-year timeline. What we do is we go to a lot of different people who have money. It could be institutional investors, it could be high net worth individuals, and we tell them that please give us your money, okay? And they give us their money, okay? And then we manage it. So we get a fund which let's say right now we have about $20 million fund. So we have people who have invested, given us $20 million. And what we are going to do now is actually go out, look for investments, promising companies in which we will deploy certain capital. And then we'll hope that those companies, those startups that we invest money in, will actually at some point make enough money for us that we will make some money and that we will return those profits also to the people who have invested in us. Those are called limited partners, okay? We as fund managers, we are called general partners, and then we have a set of limited partners. Those are the investors who have invested in our fund. So as fund managers, we are in a similar position as startups to a certain extent, because even we need to go out and raise money from other people to invest in our fund so that now we can go and invest that money into other companies outside, other startups. The other thing to remember, very important thing is the investments are not monetized until a startup exits. So what we mean by that is that if we invest $1 million in your company today, the only way that I can actually make some money is when either your company gets acquired by another company or you have an IPO, which means that you get listed on a stock exchange. So when you have an IPO is when I'm going to make my money, or if you get acquired by a much larger company. Let's say you get acquired by Google or Facebook or any of these other companies. That is such an important thing to remember, because what it means is that if I invest my money in your company, I am not going to make anything for at least 7 to 10 years. Okay? This is a very specific asset class, which is venture capital. Imagine any other, wherever else you invest your money, in stocks, in bonds, in ETFs, you always get an interest payment like every year, every month, every quarter, in fact, But with venture capital, you don't get money every month or every quarter or every year. You are going to get money, if ever, you're going to get your money after 5 years, 7 years, or 10 years, or sometimes even longer. So it's a very important thing to remember. Another very important statistic, and sadly, and a statistic, is that 90% of all companies will fail. Okay, that's as a statistic of the market. You cannot, and 90%. Okay, so if 100 companies are started today, only 10 of them are going to survive beyond 5 years. Okay, so if I have to make an investment, if I make investments into 10 companies, then I only expect, so 9 of those companies are going to fail. Okay, only 1 company is actually going to make any money ever. So just remember those statistics, okay? It's sad but true. The other thing to remember is that because it's such a difficult asset class, which means that your money is locked up for a very long time, okay? The returns that we have to generate need to necessarily be much, much higher, because if you take your money and put it into stocks or bonds, for example, this year the interest rates are 7%. Historically, the standard S&P 500 has returned about 11.6%. So given the fact that I'm going to lock up your money for 10 years, the returns that I need to generate are much higher. So let's say, it's called the hurdle rate. The hurdle rate is about 20%. Okay, I need to generate enough money, enough returns at a 20% rate. Okay, and the last thing to remember is that to have high value acquisitions or IPOs, we're talking about, historically, there are exceptions, of course, of the case, but $50 million, unless your company is making at least $50 million in revenue, it is very, very hard to have an IPO or an acquisition. Most acquisitions we would see is when companies are doing at least $100 million a year, okay? And the IPOs these days, IPO windows are opening beyond $300 million a year in revenues, okay? So you have to remember these. So these are the harsh realities of venture capital. So what are the implications of this, okay? The end of the day, okay, if I have to give you an effective return of 20% per annum for over 10 years, 7 years, it means that I have to have at least 3.6x in returns, okay, to make 20% a year. So which means if you invest $1 million, I need to be able to make at least $3.6 million or close to $4 million from this one. Okay, it's not as easy as it sounds to make $4 million from $1 million, okay? And this is the return that I need to get, okay? Then if you remember, it's a 1 in 10 success rate, which means if I invest $1 million each into every company for 10 companies, only one company is actually going to make some money. That basically means that instead of 3.6x, I need to make 36x in returns. 36x, okay? Which means for $1 million if I invest, I need to make $36 million. Because I have invested $10 million, okay, in each company, remember that. Thirdly, each round of investment that you have, okay, no company, like it's not that if you're going to take $1 million from me right now and then you're going to become a $100 million company right away. You're going to have to get additional rounds of investment. So you'll have a pre-seed round, a seed round, Series A, Series B, Series C. Nowadays, companies are having like Series F rounds even before IPO, which basically means is that I'm going to get diluted. Let's say for my $1 million initially, if I got like 10% of your company, then by the time we actually have an exit or an acquisition, I probably own less than 3% by the time. So which basically means because my equity has got diluted in your company, I actually now have to have a return requirement of 100x, okay? Which means if I input $1 million in your company, okay, your exit needs to be at $100 million for me to actually make any decent return on my money, okay? And so, if I invest in your company, or as I had expected that an investor would invest in my company at a $10 million valuation, it basically meant that if I expect an investor to invest in my company at a $10 million valuation, it basically means that I need to have an exit at $1 billion, okay? So if you remember, Instagram was acquired by Facebook for $1 billion at that point of time. Okay, that's the kind of acquisition we are talking about. If I invest $1 million at a $10 million valuation, I need $1 billion exit for you to have $1 billion exit, for me to make enough money on my fund, okay? That is venture math, okay? And so essentially at the end of the day, venture math means that it is meant for companies that can have a very, very large exit. You have to make a lot of money. You have to have the ability to make a lot of money to expect to get funding from venture capital, okay? So, it's very simple. If you want to get money from a VC, build a VC fundable startup. It's simple, right? It's not the other way around. So make sure that if you want to get money from a VC, build a startup that can actually be funded by a VC. It's pretty straightforward. And so what makes for a VC fundable startup? Okay? I have seen this so many times. Like we review close to 30 to 40 pitch decks every week, right? And we see all sorts of stuff in pitch decks. So it's not the confidence with which you can present your pitch deck, okay? That's not what it makes a VC fundable startup. It's not the projections that, okay, you can put whatever projections, right? You can say, oh, I'm going to make $50 million in 2 years. I'm going to make $100 million in 5 years. It's not the projections, right? Nothing. So the VC fundable startup is a startup that is a business that can have a very large exit in a very short time. That is all. So you have to make sure that you're building a business that can grow very, very fast and that can potentially have a very large exit. If you can show me that that is the kind of business that you're building, I will give you my money, okay? But VCs, we don't have a crystal ball, right? Like, nor do you, for that matter. Nobody has a crystal ball to kind of find out whether this company is actually going to have a very large exit and how fast we're going to have an exit. So then what do we do? So essentially what we do is we do research. We study, we learn, we talk, we dig, and we try to find out as much information as we can about every company that we talk to, every pitch that we talk to. What are some other things that we are looking at, okay? So the biggest things that we're looking at, I don't know if you've heard of this term, it's TAM, TAM. It stands for Total Addressable Market, or is also, basically it's your opportunity, okay? Opportunity size. How big is your market? In all our venture-related studies, we have found that the single biggest factor that decides whether a company will have a very large exit or if a company can actually become a very large company is TAM. Is this market big enough to build a $100 million company in 5 to 7 years? That is the single biggest thing we are trying to research. So for example, I had a pitch just the other day at this company who had, they were selling data sets, okay? So they had 3 data sets, okay? And they said, okay, we have, over the last several years, we have scraped a lot of data from different sources, and we have built these very, very valuable data sets for AI companies, okay? And they said, oh, we have 3 data sets. The first data set, we think we are going to be able to make $50 million. The second data set, we are going to be able to make about $30 million. And the third data set, again, we'll make about $20 to $30 million, and we will get to $100 million. And that's how we can build a $100 million company, and so we'll have a $1 billion exit, okay? It does not work like that, okay? You cannot say that my maximum market size, maximum revenue I can earn is $100 million, and then expect to be acquired for $1 billion. Your market size needs to be at least $10 billion, a market opportunity. Like, you have to be able to grow into that $10 billion, because imagine even the most successful companies, okay, Google and Facebook, these are slightly exceptions, right? Because, for example, Google has 90% of the search market, which is so rare, okay? But for most other companies, somebody that is called, a big dominated, a company that is, a market that is dominated by a single company, the market share for that company is not over 10%. So at 10%, we consider a market saturation, that this company has now really dominated the market at 10%. So 10%, if you are going to have $100 million, your maximum capacity is $100 million, you will never grow to more than $10 million. So it essentially tells you that your market size needs to be at least $1 billion to be able to have a company that is going to be $100 million in revenue and expect to be acquired for $1 billion, okay? So one of the very, very important, your market opportunity, you should be able to show that this company can become at least $1 billion company, okay? That's the most important thing. Team, it goes without saying, like the 2 most important things that we evaluate are team and TAM. Like, everything else can be managed to a certain extent, but if you don't have a world-class team, you will not be able to build a $100 million company. Absolutely crucial. We look at the team. In fact, in our own scoring model, 50% of our score for a company is reserved for the team. Like, we really look in detail for the team, because if the team is not good, if the team is not world-class, you are not going to be able to build this. So tech and team, very, very important. Sorry, TAM and team, very, very important. It goes without saying that you need to have some kind of tech, right? Like, you are not going to be able to build something today if you don't have some sort of differentiation, if you don't have some sort of competitive advantage. Again, this is something that we look at very closely. It has to be a sustainable competitive advantage. It's not something that, it's here now and gone tomorrow, because you're looking at time horizons exceeding 5, 7, 10 years. You need to have some sort of sustainable competitive advantage that's going to last you at least 10 years, okay? Next thing that we're going to look at is traction, which is what kind of signals are you getting from the market, okay? Who wants this? How big a problem is it, okay? Who's willing to pay for it? What is the average size of your order? Is it, if you're going to charge $5 per license, are you going to charge $50 per license, $500, $5,000 annually? That changes a lot. If you're going to be charging people $5 for a license, you need to get millions of users to actually be able to make $100 million, right? So we like companies that have higher ACVs, which is annual contract values, 5,000, 10,000, 50,000. You know, that makes us happy, rather than something that's going to give you, you know, $20 a year. That's not a sustainable business model. Market timing, again, very, very important. What are the macroeconomic conditions? How are the macroeconomic conditions changing? Are there any new technologies happening? Are there any new behavioral, attitudinal changes in the market? Are people changing in the way that they're interacting with technology? What is the market adoption? All of these things are very important, because if your market is not ready, remember, Microsoft had a tablet called the Newton that they released in 1993. Okay, so they had a tablet at much before the iPad came into the market, but the market was not ready. So just because you have a product that's innovative, that's useful, does not mean that it will be adopted by the market. So market readiness is, again, something that is very important, and that we look at the macroeconomic factors. And finally, we look at momentum, which basically means that velocity. Like how fast are you growing? The only thing that actually differentiates a small business from a startup is velocity, okay? You can have the same startup, you can have two businesses, each one doing $10 million a year, but one is a small business and the other one is called a startup, because the startup is growing at 30% month over month. Okay, the business is growing at 1% or 2% year over year. A startup is growing at 30% month over month. That is what differentiates a startup from a small business. So momentum is absolutely important. Why? Because our time horizons are 5 years to 7 years. We want you to have an exit between 5 and 7 years, which means velocity is really, really important. Okay? So what does all this mean for you and for me at that point of time? Okay? So first and most importantly, please evaluate your business. Okay? We took a very long, hard look at our business, and we concluded that this is not a venture fundable business. A venture fundable business, as I told you, has certain very typical characteristics, and you have to evaluate whether your business actually is venture fundable. And if not, that does not mean it's a bad business, right? Making $5 million a year is not a bad business. It's a very good business, but it's not venture fundable. And if it is not venture fundable, then you have to find other ways in which to fund your business, okay? And there are other ways. Venture capital is not the only way to fund a business. You need to look for other funding sources, and that's perfectly fine. Not every business is venture fundable, and there are thousands and millions of businesses that are very successful. The founders are making a lot of money every year, which are not funded by VC. So VC is not the only game in town, and it's always possible to find other sources of business if it's not venture fundable, okay? So if that is the case, then either pivot to a business, you can change your business to either something that's venture fundable, or you can find a different source of funding. First, so now if you evaluate it and you think that your business is venture fundable, which basically means it has a very large TAM, it can become very large, it can become very large very quick, and then you can have an exit within 5 to 7 years, then validate all of those. You have to document every assumption that you make about your business and run experiments to find evidence that supports your assumptions, right? Execute, okay? You have to have really world-class execution. In the world of VC, velocity triumphs everything else. You have to be very, very fast. You have to get to $1 million in revenue within the first 12 to 14 months. That should be your target. After you get to $1 million in annual recurring revenue, the next 5 steps are triple, double, double, which basically means once you first hit your first $1 million, then the next year you need to hit 3 million, The year after that, you need to hit 9 million. The year after that, you need to hit 27 million, 54 million, and 108 million. That is supposed to be a trajectory for the next. That's the kind of velocity that we are looking for, ideal velocity that we're looking for when we invest in companies, right? And finally, most important, where all the founders, like 95% of the founders that we meet get this wrong, is this part. You have to be able to show evidence and not just tell. You can't just come and say, oh, my business is going to be $1 million. It's going to be $100 million business. You can't just say it, okay? What's the evidence? Everything needs evidence, need to be backed up with data, okay? You must run experiments. You must be able to show, purchase orders, LOIs. You have to have agreements. You have to have whatever that is necessary to put in place to have evidence to back up your claims that this is going to be a very large business. You have to interview people. You have to talk to at least 100 different people, get their feedback, show this is a big problem, show that this is a really burning problem, show that the solution that you're building is an important solution, show that this is a sustainable business model, show that this can have enough margins. That you need to have, you're looking at businesses, you need to have at least a 70 to 80% gross margin to actually make some money at the end of the day. So all of these things need to be substantiated with data and with evidence. You can't just come in and say, okay, my business is going to have 80% margins. No, I'm not going to believe you. I need to see evidence of this, okay? So that's the most important thing. Document every assumption, experiment, validate it, okay? And then show that. Make sure that you're able to prove your claims about anything that you tell your investor. If you're able to do this, you are going to get my money, okay? So reach out. We are actively investing currently. Those are my coordinates. And I'm happy to walk you through, help you. We at Sprout Fund, we are big on mentoring. I'm personally mentoring at 3 different accelerators. 2 of our other partners are also in different growth accelerators, at 500 Global, at the Growth X Accelerator. And we are more than happy to assist founders on their journey. So feel free to reach out. And if there's in any way I can assist you in your evaluation, then let me know. Thanks a lot.
Okay, I think what we're going to do is we're going to shift to a break a little bit earlier, and there's some coffee and do a quick question, or okay, one question from Sean, but we are after the break going to have a panel. We'll get the entrepreneurs back up and then chance to ask more. But Sean.
I think TAM is one of the biggest challenge for a lot of founders that I've found, right? So let's give you a very good example, right? Tomorrow I come to you and say, hey, I want to sell toilet paper. It's an AI-generated toilet paper that form in your hand and wipes better than anything else. The TAM is super big. We're talking about $100 billion market. Except now I'm going to sell this thing at $100 a pack rather than $15 a pack. Obviously, my TAM is there, but I'll be a lot of founder or younger founder, they will say, oh my God, I think I can sell to 10. There's only, there's 1,000 millionaires in Vancouver, and I can probably get 10% of it. All of a sudden, boom, the volume is this big. So are they supposed to pitch you $100 billion? Or are they supposed to pitch you maybe $100 million?
So whatever you pitch us, irrespective of the numbers, we are going to take a very long, hard look at it. Okay, I'm not going to accept, just because you say the TAM is $100 million, $100 billion, I'm not going to accept it at face value. Again, I'm going to look for evidence of that. So the best way to do this is what we call as bottom-up sizing. And so to tell you the truth, I don't like the acronym TAM. Okay, I don't like that TAM, SAM, SOM, all that nonsense. In fact, whenever I interact with founders, I tell them, don't give me that. I'm not interested in TAM. What I look for is what I like to refer to as opportunity size. Okay? I call it opportunity size, and opportunity size is estimated, is calculated from a bottom up. Okay, and so first and foremost, it's important to try and get evidence of what is this, how much can you sell this thing for? Okay, and there are people out there who are actually going to buy this. So that's if you don't have that evidence, I'm not going to believe any of the numbers that you're going to. And we do a bottom-up sizing, we do a bottom-up opportunity size calculation. Okay, there are 1,000 millionaires in Vancouver. We have talked to 100 of those, and they are willing to buy my AI-enabled toilet paper dispenser at $10,000 a dispenser. And so this is the evidence that we have talked to 100. We actually have a purchase order for 10 of those. We have letter of intent from another 10. They're willing to purchase this, and that is how we would actually go about calculating. And we also do reference checks. We will call your customers. We will call the people that you have talked to actually get the feedback directly from them to understand that, yes, this is real or not. So anything that you tell me, I'm going to question anyway. So go bottom up is the best way to find out how much it's going to cost, what's the possible market size for, like, number of people who can buy it, or number of companies who can buy your software for that matter, and then do a bottom-up sizing. That's how we look at opportunity size.
You're a sky full of stars. I'm gonna give you my heart. 'Cause you're a sky full of stars. 'Cause you light up the path. I don't care, go on and tear me apart. I don't care if you do. 'Cause in the sky, 'cause I wanna die in your arms. Oh, oh. 'Cause you get lighter the more it gets dark. I'm gonna give you my heart. Oh, I don't care, go on and tear me apart. I don't care if you do. 'Cause in a sky full of stars, I think I see you. I think I see you. You're a sky full of stars, such a heavenly view. You're such a
From harvests full of flavor to valleys full of life, fall has it all in BC's wine regions.
We come to you from the mountain of entertainment to show you what's streaming on Paramount Plus. Blockbusters like A Quiet Place Day One, originals including Yellowstone, and hits like Dexter.
Stream Paramount Plus from $6.99 a month.
yourself try. It's true. Look how they shine for you. Look how they shine for you. Look how they shine. Look how they shine for you. Look how they shine for you. Look how they shine. Look at the stars. Look how they shine for you. And all the things that you do.
The new A&W Ruffles Crunch Teen Burger.
Let's go.
Juicy grass-fed beef topped with Ruffles cheddar and sour cream chips.
Let's go!
Try the new A&W Ruffles Crunch Teen Burger. Let's go.
Oh, that was a big one.
Still dry?
Yeah, still dry. I'm Andy from Vessi, the makers of waterproof footwear. We can assure you Vessi shoes are actually waterproof. Our patented waterproof tech covers your whole foot. You can take your dog out for hours when it's wet. But people love us for commuting in any weather and staying super comfortable. The reason we're so obsessed with water, it makes us happier, healthier, and reduces stress. So why wouldn't we be?
I used to rule the world. Seas would rise when I gave the word. Now in the morning I sleep alone. Sweep the streets I used to own.
Sorry to interrupt your networking, but we would love to get a group photo outside just before it rains, and that way everyone gets outside to have a look at the beautiful view. So I invite everyone to come outside so we can do a group photo. Please go through these doors or the ones over there. Thanks so much, everyone.
King is dead, along with the king. 1 minute I held the key. Next the walls were closed on me, and I discovered that my castle stand upon pillars of salt and pillars of sand. I hear Jerusalem bells are ringing, Roman cavalry choirs are singing. Be my mirror, my sword and shield, my missionaries in a foreign field. That was when I ruled the world.
New DQ Fall Blizzard menu. Returning pumpkin pie and French silk pie. This lineup is the GOAT.
Taco?
No, like the greatest of all treats kind of GOAT.
Oh.
Hurry in before they're gone. Only at DQ. Happy tastes good.
Michael's lowest prices of the season. Take up to 60% off thousands of items like fall floral, decor, and more. Score huge savings on beads and great deals on frames. Oh, and you'll love this. All yarn is on sale. Shop today. Sale ends soon.
Wipes too harsh? Switch to Garnier Micellar Cleansing Water. Micelles work like a magnet to gently remove makeup without rinsing. Skin looks perfectly clean and hydrated for 12 hours. Suited for sensitive skin. From the #1 micellar brand worldwide. By Garnier, naturally.
From harvests full of flavor to valleys full of life, fall has it all in BC's wine regions.
We're building something. We have to think big.
What do you know about wind turbines?
I know they blow.
You're an outsider. Tulsa is mine.
We might have some trouble coming our way.
If you want to build a future, you gotta know what you want.
We in this together. You want to go down fighting?
I don't answer to anybody.
Blew down the doors to let me in. Shattered windows and the sound of drums. People couldn't believe what I've become. Revolutionary sway. For my head on a silver blade. Just a puppet on a lonely string. All who would ever want to be king. I hear Jerusalem bells are ringing. Roman cavalry choirs That was when I ruled the world.
Okay, we're going to get started again with a short panel. A chance for some Q&A. I'll start with a few questions and then open it up to the rest of the folks here today. So maybe I'll start on with Abel. And we just heard from Abhay about how hard it is to kind of to grow and get those kinds of numbers and the markets and everything. I want to just hear from the entrepreneurs. And by the way, Abhay was also an entrepreneur before this, so that'll probably be a question for you is what's more fun, being a VC or being an entrepreneur? But we'll start with Abel. What motivated you to take the plunge and start your own business?
So I think I have like two different motivations. One of them is that through my other business we develop, I've seen so many companies failing to hire the people they needed because they thought that the profiles of those people weren't a good fit. So I was in a situation where I had the client and I had the person for that project. I've seen the match already, and the company says, "Oh, well, no, this is not a good fit because this and that on the profile," without even talking to the person. And my second motivation is that when in some career transitions, I had extensive experience in some areas, and I was kind of forced to reduce those experiences into 3 or 4 bullet points. So I don't know, that frustrated me over time, and eventually I decided to do something about it.
Okay, thanks very much. Sounds good. How about Dinakar? Maybe you can just pass the mic over down the line here. So the question was kind of what inspired you to start your own venture?
For me, what inspired me to start my own venture is that I've been, like I said in my presentation, I was in the industry for 4 years, marketing for other businesses, and one issue that comes for me is just the repetitive task, and that's just the personal frustration. So I decided to set out and solve the issue for myself, and hoping that the rest of the businesses that will follow. And the second thing that frustrates me the most is that I like how the whole industry is called marketing automation, but if so many people have to work in an industry, what are they even automating is kind of where I'm getting at. So I feel like tools, they have to be more intuitive and more engaging, and that's where I think Hetero can come in and sort of bridge the gap that I see in this industry. I hope that answers your question.
Okay, thanks a lot. Moving over to Abhay, and maybe a little bit unique for you, because you've seen kind of both sides of things. First of all, what's more fun, being a VC or being an entrepreneur?
It's a tough one. both are equally hard. So just because you are now have money to deploy does not mean that it's easy. And now it's somebody else's money that we're responsible for. We have a fiduciary duty towards our investors. So sourcing, and you see the bar that you have to meet for a venture-funded company is so high that trying to find those real nuggets that are actually going to be able to get to $1 billion, it's very, very difficult. So sourcing is really hard. And so it's a lot of a sales job, very similar to us being an entrepreneur, where you have to constantly be selling and thinking about where you're going to get your leads from. So there are a lot of similarities, of course, and I enjoyed both the roles. For the first part, as an entrepreneur or as a founder, frankly, I don't know what else I would have done. Like, I want, you want to have that, to be able to make a change in the world. Like, you want to build. I wanted to build. I want to actually, whenever I see something that's not the way it is, I don't want to wait for somebody else to fix it. I want to make that change in the world, and that has to drive you to build. Otherwise, entrepreneurship is so hard that if you don't have that inner kind of motivation, you're just going to give up very soon.
Okay, yeah, I hear a lot of times if you ask an entrepreneur for one piece of advice, the first thing often they say is, don't do it. And then they say, just go for it. Okay, over to Eric. What inspired you to take this pathway?
Well, I believe it's more about testing myself to see if I can fail. I was saying that it's about testing myself to see if I can succeed or fail. Right now I'm doing 3D printing, and it wasn't my passion at the beginning, and now it is. So I think I built passion for business because I know I can do it, and I'm willing to fail, rather than just trying to solve a problem. As you, I'm not trying to solve a problem. I'm testing myself. I'm passionate about that.
Okay, passion sounds good. Majid, you've done a lot of higher education and I think PhD, right? So why did you pick the kind of entrepreneurship pathway versus the more academic pathway?
Actually, the field that I'm working on that is the same as my background, and the things that I find it very difficult is to how you can run a business, getting money and raise money, and all the things that we are involved with that. And all the time you have some stage you should pass, you should bring it through, you should release new version for your product, and you should do some bullet points. But all the time when you want to pitch, you need to prove something more, and something more needs money, and your pocket is not so deep. So yeah, this is the challenge: how you can manage money, and how you can get money, how you can raise, and yeah, that's it. As I'd say, both sides is difficult. As an entrepreneur, you need to raise money. As a VC, you should take care of your money, how you should put your money, and yeah, both sides has some challenges. And yeah, that's it.
Okay. Now the next one, it doesn't have to be everyone, whoever wants to take a stab at it, but where are the biggest opportunities in heterogeneous computing, data centers, AI, high performance computing? We've heard from some pretty cool speakers and applications. Who would like to take a stab at that, where you see the biggest opportunities?
Okay, I will take that. So I think that in terms of innovation, we are still a few steps ahead of actually incorporation of that technology. I think that right now we have more technology than the technology we actually use. So for me, what is needed in the next few years is to have a very practical eye in terms of what's the end value that whatever technology that we are developing gives to the end user of it. I think that would be my take.
Okay, it's a very tough one. I've been out of this field for a while, but obviously, there was a time when I was working on this. There are so many scientific challenges currently. I mean, that's also one thing. Of course, AI everybody seems to be talking about these days. So definitely, it's going to be like LLM trainings and clusters. We know that people are investing over $100 billion. Just 5 companies are investing $100 billion on data centers in the next 5 years. So that's a lot of money being invested on AI, but there are so many other, regular scientific technical challenges where heterogeneous computing can be useful. Space exploration, medicines, healthcare. They're just everywhere. Like everywhere we need computing, we are going to need to be able to utilize heterogeneous computing to make optimal decisions for the efficiency and utilization of the workloads.
Okay. Anybody else want to take a stab? No, all right. And I guess sort of related to that, when you're talking about the big markets you have to go after in this field of heterogeneous computing and data centers and AI, is that really the main approach? Is VC capital? It just takes so much money? Or is that the kind of business you can do on a smaller scale, or it just doesn't work?
It's a tough one, actually. So what's happening in most of them are, in fact, what we see is a lot of the VC money is actually being used to just buy compute, just buy resources for like the NVIDIAs. So it's kind of just taking money from VCs and everything is going into NVIDIA's pocket at the end of the day. So it's a tough one. We don't really like that. Like that's not a good utilization of VC dollars. VC should be used for scaling. Ideally, you don't want to use it for hardware. There are other ways to fund hardware purchases and that you can do. You also see a lot of like the AWS investments or Azure investment, like the Microsoft investments. They are just investing in terms of credits. So $10 billion worth of credits on Azure for OpenAI, in fact. So there are different ways in which you could potentially fund this. The kind of opportunities that we look for, like as VC does, would be like something that's more, that's going to, rather than buying infrastructure, if you can actually put in fabric, like like scheduling algorithms, optimization algorithms, or talking about data storage optimization. That's also a company that we are evaluating right now, which is talking about reducing the data storage requirements by 25% at the very least, like as a minimum. So those kind of applications are something that we would much rather put VC dollars in, rather than to buy up, GPUs and just set up data centers. That's not a good use of VC dollars.
Okay, we heard from Professor Lee, Professor Pinikenko about, for example, the second presentation, commercializing through SentML. What do you think about the pathway of professors commercializing their R&D? Any tips for any of them? Majid, you were also in academia, now you're doing startup. For either of you, and I know there's some professors probably here that also, have aspirations like that. How do you decide, like you do both academia and these startups, or just one or the other? Sometimes you have to make a decision.
Okay, this is the things that I decided to pass MBA courses to get familiar with the market, with the how can I run a business and like that. Sometimes I find that I'm not the one that going to the university and instruct for people. I'm the man to go to business and find my business. So this is a tough decision because my career was all the time in the same things, in machine learning, academic background, and the way that I decide to run a business in this field, and yeah, that was like that.
Okay, sounds good. Now we have a lot of students here from either IT fields or entrepreneurship business fields. I'd like to get each of your one piece of advice for up-and-coming entrepreneurs, starting with Abel.
So I had an experience myself, wasn't intentional, but it just happened. So I started the company very early in my career. That was a consequence of selling my personal services. So I am a software engineer, so I had a few clients, and I used to work with those clients directly, so I was like providing a service instead of being an employee. And eventually those clients wanted more and more from me, so I had to hire people. The result of that was that after a few years of working as a freelancer, I ended up working as the CEO of a company that was making recurring revenue out of a service-based company, which is not very VC fundable, but as Abby said, was a good business, was making money, is making money, and that company allowed me to later bootstrap a few ideas. All of them failed. I am actually now on a new idea that most likely will fail again, but my point is that don't rush to try to fundraise and try to open a business, incorporated business, and build a pitch deck and build a business. Maybe first my small piece of advice would be try to generate some asset that puts money into your pocket, that pays the bill, and gives you that free of mind that enables you to later, build the business. Also, the time and the money as well.
Thank you, Abel. I like this question in particular because this question kind of caters to students, and I graduated with my MBA last year, so I'm still in kind of the student mindset, if you will. The only thing I think about this question is that to get started as soon as you're willing to get started. I'm saying that because at some point in life we'll try to think, oh, I wish I did it that day. And today is literally that day. So a best day to get started is the present moment. So if you have an idea, I would suggest working on it, even if it's just a little bit, just like having an Instagram page, or just creating a website, or just creating a freelancer profile with your skills or whatever, and just like posting it out there. Having an idea is one thing, but then getting that idea out there and getting it to reach an audience is a whole another thing. Keeping that idea to yourself. Say you have a book to publish, but you're not publishing it, you're just writing a page every day for 10 years, where is it going to go? It's not going to go anywhere. You have to publish it, and that's the day you become an author. So that's what I would say, is to keep pushing and keep publishing. Push your work outside so that the people can see it and the right person will find you. Yeah, that's about it.
Thank you.
Yeah, so when Abel said that he was selling his services, I was a bit scared. Like, what is he talking about? I thought maybe, he has OnlyFans or something like that. So I initially got scared. What is he going to say? I was selling my services for when I was a student. Anyway, that was a joke. My only piece of advice, as from an entrepreneur point of view, talk to customers. You absolutely, before you do anything, if there's one single piece of advice that we give every founder, talk to your customers. Talk. You have to talk to them. You have to learn from them. You have to get to know them better than they know themselves. So before you do anything else, talk to your customers and have a bias for action. Anything, try to execute very, very fast. So talk to customers and have a bias for action. That's my suggestion to you. Thanks.
Thank you, Eric.
So I'll say that for me it's more about doing than planning. I found that the more I plan, the less I do. So I spend a lot of time figuring out how much I'm gonna make and trying to maybe have a business. Like I'm gonna make $10 million, and I spend a lot of time writing down the path. But I think about the figure, but I don't think about the how. So I'd rather start doing than planning, and don't think about the money you're gonna make, but how you're gonna make it. And I agree about talking to your customers. My businesses have all been in manufacturing, so every time that I build a product, I have to talk to the customer. I cannot take any chances and just build something believing that it's gonna work. So I go, well, we work for many corporations, and we have meetings where we spend an hour or two talking to the customer about the needs, their goals, and after we figure out what they want, we come back to them maybe in a week or more than that with a solution that will fit their product. And only by doing that we have become successful in the past. Yeah.
Okay, lots of great advice here. Last but not least, Majid, what would you recommend?
The only things that I want to add to the talk is build your roadmap. You know now about the milestone when you want to release your product, when you want to launch your market, what is your strategy for go-to-market, and now when you are in which position. And if you know about all the roads before you start, it's already everything is crystal clear for you, and you have better idea what should you do in every step.
Okay, so some really good advice from the five of you. Thanks so much. We have a couple of minutes, just any questions from any of you here. Anybody want to take a stab at it before we get back into the technical side of things? More technical. Yes. All of it? No. Start. Who would like to take a stab at that one?
Okay. In my experience, things get messy very quick. So the moment you start doing anything, you may think that, oh, this is just a test, just something, and next day that's huge. I have an example. So a friend of mine wanted to make an Instagram with AI-generated content. So he goes, I will use ChatGPT, open the Instagram account, and start posting things. And eventually, he says, in a few days, if I get traction, I will continue this business, right? That eventually meant a lot of months. And yeah, something that he thought was going to take, a few hours every week was taking a few hours every day. So in my opinion, again, in my experience, even the most simple thoughts will represent very intensive execution. So yeah, just be careful.
For me personally, the hardest part was to get direction in the things that I want to do. I'm saying that because when you're working for a boss or a company, you have someone on top of you and they're going to tell you what to do. But then when I'm working on my own startup, there is no one putting that pressure on me. It's just me working for myself, for getting my own vision. So it's really easy to get lost. It's really easy to lose a sense of direction. What I did to solve this issue is to come up with a plan for 5 days of the week. What I did is that Monday is just for marketing, and Tuesday is just for admin task, and Wednesday is just for, say, my focusing on my website, creating pages or blog posts or whatever. So that way I was able to divide and conquer parts where I want to focus on. And I'm saying this because when you have multiple things and you're juggling between things, it's easy to lose focus on stuff. Say you're writing a blog post, for example, and then you're getting an email from someone, and then you jump back to email and you want to reply to the email, which is great. You have to reply to your emails, especially if it's an important client or customer. You have to reply to them, but there is a time and place for everything. And if you're jumping from one thing to another, it's just really easy to lose focus on it. So what I would say, the hardest part was to gain focus and get what I want to do and do exactly that to solve that, and before moving on to something else. It's easy to get started with one thing and move on to the next shiny thing, but it's way better to stay focused and to stay disciplined on one thing and complete it, and then move on to the next chapter.
I'm just going to be quick. So, Frank, entrepreneurship and startups is the fastest way to lose your hair, as you can tell from my trust me. There are just so many instances, like so many things. I've been at it for 15 years, and there are so many hard, tough points that you have to face. Recruitment, fundraising, sales. It's just non-stop, especially if you take VC capital. It makes it even worse because then you have to maintain that velocity and you have to keep growing, and it's constant, non-stop pressure. The fastest way to lose money and lose your hair. And so you have to be able to withstand that kind of pressure. Then, letting people go, that's also very tough. I've closed down 2 businesses, so that's also a very, very tough decision, and when to decide when you have to close down. So it's just tough. As Siri was saying, the best advice is, if you don't have that inner drive, that motivation to be an entrepreneur, then don't be one, because it gets very tough. Okay, thanks.
How's that for encouraging? Okay. Eric.
Well, to me, it was becoming very eloquent about my company, so I can put my message across to my customers. Sometimes you believe that you have the best product and you are the best, but then when you have your customer, and sometimes you only have one chance, you're gonna put your message across. So you become shy, you don't trust yourself, you are arriving to the appointment with high expectations, and when you see the face of the other person that is not paying any attention, you just depress yourself. So you have to have a really high esteem, have to be very eloquent. So that's more on the personal level. But after that, I don't think anything else matters. If you become eloquent and have self-confidence, I believe for me, it's number one.
Okay, thanks, Eric. And Majid, you have the final say.
Actually, all the part is difficult, promise you. And if I want to tell you every part, finding a specialist is very difficult, fundraising is very difficult, sales, marketing, everything is difficult. But if I want to say the most difficult decision that you can get is closing a business. Sometimes you should think about that. And I had closed one business before, and in that point you should decide, because the cost will kill you. So you should take care of the cost, and sometimes the best decision is closing the business.
Okay, some painful medication there. All right, I think we're going to run out of time, but there will be a chance right after the next couple of presentations for talking to the folks here. So entrepreneurs are super busy people. All 5 of you have taken time out of your super busy days to be here, so let's give them a round of applause. Thanks very much. Okay, next up we have Dr. Lee presenting. I'll just get your slides ready. And we're so happy that you could make it here to Vancouver. Thanks so much for coming on pretty short notice, and really excited to hear about your presentation. Let's give him a hand again.
Thank you so much. Okay. So today I'm going to focus on very specific problem about the GPU memory capacity problem. So recently, we have been facing this shortage of GPU clusters, right? You probably heard about this story. This GPU shortage not only push up GPU prices, but also brings challenges to a lot of business. On the other hand, we see the GPU memory capacity is becoming a scalability bottleneck. Look at the figure. I don't know how many times you have seen this figure, but this figure shows you that in the last couple of years, the model size increased more than 5,000 times, but memory capacity increased only by 2.5 times. Obviously, the GPU memory capacity is not catching up with the model size increase. So how to solve this memory capacity problem? We could use distributed training, right, with the various parallelisms. You know, we could use data parallelism, tensor model parallelism, pipeline model parallelism, and so on. The problem is that to enable these solutions, you have to use more GPUs, right? As we mentioned at the very beginning, we face the GPU shortage problem. So this solution basically gives you unaffordable monetary cost. Okay, so what should we do about that? How should we solve this problem? One solution is about tensor offloading. It's called tensor offloading. Basically, you use CPU memory as extension of GPU memory, and then you offload some tensors from GPU to CPU. And then you migrate the tensor back to GPU when the tensor is needed by the computation there. So you move tensor back and forth to save GPU memory. So this is a very strict solution. But this solution faces many challenges because the tensor movement is expensive. You need to consider which tensors to migrate. You have so many tensors to take care in a single large AI models. And you also need to answer questions like what is your migration granularity? Whether you should migrate at the whole tensor level or individual tensor elements level. And how should you prefetch tensors, in order to overlap tensor migration overhead with GPU computation. And also, if you have 2 copies of the data on CPU memory and GPU memory, how should you take care of the tensor coherence? So there's a serious problem, serious questions to answer. But the most fundamental ones behind all of these questions is about how to enable large AI model deployment and training while minimizing this tensor migration overhead. This is the fundamental question we need to answer. And our group has been working on this topic for a while. And this graph, this figure in this slide summarizes our effort and how they are related to each other. And we have been deeply look into the transformer-based model. And one of the work called Zero Offload has been integrated into Microsoft DeepSpeed. And we also have been looking into the graphic neural network, a traditional machine learning model. And very recently, we look into the deep learning recommendation model, collaboration with Meta. And we also look at the implication of emerging CXL memory on the tensor offloading. So I have been doing a lot on this topic. But in this talk, because of time limitation, I'm going to just focus on this very specific work called the dynamic neural net offload. And in this work, we use a learned approach to guide the tensor migration between CPU and GPU. Learned approach basically means we use a machine learning model to guide the tensor migration. Then the big question is, why do we want to use a machine learning model? Now, to answer that question, let's look at how the existing work is trying to manage the tensor migration. Existing work is using a profiling guided optimization to guide the tensor migration. The idea is as follows. Basically, you give me a few training samples, right? And then I'm going to run the samples through this model, through the pipeline. During that time, I'm going to collect the tensor size, how many times each tensor is excised, what the lifetime of tensors, and so on, so that we can make a systematic plan on tensor migration. Which tensor should migrate, and when should that migration should happen? So things like that. This method is based on a fundamental assumption. The assumption is that the profiling result collected during the profiling phase is valid for the other training sample. So no matter how you change the training samples, the model structure remains the same. The profiling result will be valid throughout all the training samples. So this is a basic assumption. But this assumption is not always true. What about dynamic neural network? And recently we see the emergence dynamic neural net, right? It includes the mixture expert and many other type of neural network. This neural network has a very unique characteristic. The model structure or parameters can be changed depending on your input sample. And such change is controlled by confidence-based criteria and gating functions using control flows. To understand this dynamism better, let's look at a very specific model called AlphaFold. So you probably heard about AlphaFold, right? AlphaFold is a model to predict protein structures. So the AlphaFold, the prediction process is controlled by this iterative process. And in each iteration, we are going to refine the prediction result based on the information collected so far. So you can see that over here we have dynamism. And meanwhile, if you zoom in the AlphaFold, you will see that inside the model we have this gated self-attention to decide whether a specific attention mechanism will be activated or not. But overall, you see a lot of dynamism within this model. So this basically means the profiling guided optimization, the traditional method, cannot work. So what can we do about it? To solve this problem, we introduce a solution called dynamic neural net offloading. So it's very designed for neural network or large AI models with dynamism. Our solution is driven by a couple of observations. The first observation is the training process of a neural net exhibits learnable patterns. For example, usually your linear computation will be followed by nonlinear computation, right? So this kind of a pattern is highly learnable. You can capture this pattern, implicit pattern. And another observation is that the dynamic structure of dynamic neural net is based upon a serious decision-making process to activate the model components, which in turn impacts access order of tensor. So this basically means the input sample to dynamic neural net provide indication on how such decision-making process occur. So we can literally introduce a prediction model called a pilot model that can be learned to enable automatic synthesis of decision-making process before the AI model or dynamic neural net model even process that sample. Okay, so this is the basic idea. Basically, we introduce a pilot model ready from dynamic neural net, and during training, you feed input sample to the pilot model. Meanwhile, you feed the same input sample to dynamic neural net. But this pilot model is supposed to resolve the dynamism in advance. It can help to decide when to prefetch which tensor from CPU memory to GPU memory. So the pilot model provides guidance for tensor prefetching. Okay, so this is a very basic idea behind the work. But in order to use this idea, we also face challenges. As you can see, the pilot model itself is in the critical path, right? It's in the critical path. And we need to be very careful about managing the parallel model inference overhead. Meanwhile, we notice that to decide when to prefetch which tensor is a quite challenging problem. We have so many tensors to take care of, and we have so many transformer blocks. So the complicated prediction task may be inevitably complicated your parallel model complexity. So we need to build a trade-off between the parallel model inference overhead and the parallel model accuracy. So how to minimize the performance impact occurring in the parallel model for memory management? This is a question. This is the most challenge we have to solve. Okay, now let's see the design of parallel model. So I say, so the parallel model in nature is an AI model. So like many other AI models, you take input features and then generate output. Now look at the input. Now let's look at the input feature. So input feature include the input sample you are going to send to the Danny neural net. It also includes static structure of Danny neural net. Basically, static structure include all the model components in neural net. The input feature also include the basic neural net type. It could be convolution-based, it could be LSTM-based, it could be transformer-based, and so on. The static structure of a Danny neural net is the most challenge to build. It needs to be simple. First, it needs to be simple because we want to reduce the input feature space so that the parallel model can be lightweight. Meanwhile, the static structure should be informative. This representation should be informative so that we can distinguish different neural network operations. To meet this requirement, we introduce a idiom-based representation to encode static structure of Danny neural net. The basic idea is as follows. For each operator in an AI model, we found that it can be commonly characterized with 6 pervasive and expressive idioms. So I list those idioms in the slide. But basically, for each operator, we can automatically build a signature using the idioms. For example, this specific operator, we can build a vector with 6 elements, and this each element count the occurrence of each idiom in the operator. And then, based on this idiom-based representation for each operator, we are going to build a matrix for Danny neural net. Basically, each row of matrix corresponding to one operator in your static structure of Danny neural net. It includes the idiom-based representation and also include the input tensor shape. And this operator order, this row order represents operator order. Okay. As you can see, this representation is highly compact. It's simple, it's single metric. And also, it's quite informative. It can tell you the memory access pattern, input tensor shape, the order of those operators in your static structure, and so on. Very informative. So it basically can meet your requirement on how to represent the static structure of your Danny neural net. Okay, so this is the input. And how about the output? How about output parallel model? Remember, the output parallel model is supposed to decide when to migrate tensor and which tensors to migrate from CPU to GPU, right? And these are very difficult goals to represent using something mathematical. How should we represent these 2 goals? And we use a execution block-based representation. What does it mean? This basically means, suppose that we have this Danny neural net, and it has been activated. Look at the dotted line, means the activated components. And we divide this static structure of Danny neural net into execution blocks. At the beginning of each execution block, we are supposed to migrate tensor for next execution blocks. Because this way, we are able to overlap migration with computation. And basically, if you tell me how to partition your Danny neural net into those action blocks, I will be able to answer those 2 questions. In particular, when to migrate tensor and which tensor to migrate. Okay, so this action block representation will be our output format. And in this example, we have 3 action blocks representing the partition method to partition this dynamic neural net. And we use idiom-based representation to represent these 3 action blocks. And each row of the matrix is a accumulation of idiom-based representation of action block, which has activated operators. So again, you can see this is a very compact output format. And to use this format to guide the tensor migration, we still need to map or decode this output to operators in dynamic neural net. So what we need to do is we basically traverse dynamic static structure, meanwhile the book keep the operator information. Once we find any path during the bookkeeping is aligned with output format, then that path will be picked to decide the tensor migration. So that's the basic idea. Okay. Now let's look at the parallel model itself. The parallel model itself is a lightweight mixture expert. So it only have 3 MLPs run in parallel, and during inference, only 1 MLP will be activated. So using 3 MLP in parallel can reduce inference time, as you can imagine. Meanwhile, we improve accuracy. And this is a very lightweight model. And how about training the parallel model? You know, parallel model is just AI model. Is not nothing fancy, but we need to build a lot of training samples to make the parallel model effective. So the training sample, as you can imagine, need to include input vector and output vector. The input vector include the encoded static structure of dynamic neural net. We already see it in the previous slide. And also include input sample to dynamic neural net. An output vector in a training sample is supposed to tell you the ground truth, right? It's supposed to tell you the ground truth. In our scenario, in our context, the ground truth basically means how should we migrate tensor such that the tensor migration is overlapped with computation as much as possible, so that we can reduce the tensor migration overhead. And that is our ground truth. So how should we find such ground truth? What we do is we just feed a training sample into a dynamic neural net, resolving dynamism, and then we literally transform the dynamic neural net into a static neural net. And then we use the existing solutions for a static neural net to decide the ground truth, or in other words, decide the best migration plan. Okay, so this is the whole story. Now let's see some evaluation results. We evaluate system using a desktop level GPU and also 200 server with A100 GPUs. And these workloads we evaluate, including convolution-based, LSTM-based, and transformer-based. We also include a production code called AlphaFold. So this is a transformer-based production code. And we compare our solution with 3 baselines, including one called DTR, and UVM from NVIDIA, and the zero offload from Microsoft. So DTR is a solution that saves GPU memory by freeing memory space for activation tensor when the GPU memory is not large enough, and then rematerialize the freed activation when needed. So as you can imagine, with DTR, we have to do the recomputation. And UVM, you're probably familiar with UVM. This is provided by NVIDIA. Using UVM, we actually have a unified vertical address space across both CPU memory and GPU memory. And the zero offload works only for static neural net, but not for dynamic neural net. It offloads specific tensors such as optimize the states and full precision parameters to CPU memory. Now let's look at the result. First, I want to see whether our method can effectively break in the memory capacity wall. And in this table, we show the largest trainable model on a single A100 with 80 gigabyte memory. Compared with those existing solutions, our solution enables up to 6.3 times larger model training. And in this figure, we are trying to show the training time. We use different models, and we change batch size, and we compare our solution with other solutions such as UVM, DTR, and so on. And we can see that from this figure, we can see that UVM, which is shown in this triangle curves, the UVM performs worst in almost all cases. This is because the tensor migration largely happens on demand. The tensor migration overhead is exposed to the critical path. And even though user prints some hints to guide the tensor migration, but the user, such hints just cannot be effectively providing guidance to the tensor migration. And we also outperform DTR by 35% on average. This is because we don't use recomputation, right? That saves overhead. And even for static neural net, our solution outperforms zero offload by 33%. This is because we are not only focused on specific tensor, we are focused on all the possible tensors for migration. Okay, this is my last slide. So throughout this 20 minutes talk, I want to give you a takeaway message. The message is that building a fast, accurate, and live machine learning model can be very effective to guide the performance optimization analysis for dynamic neural net. And this method is also feasible. And we see that the dynamic neural net is becoming an effective solution, and it represents the future of the AI models because it can be highly parameter efficient and the training can be highly efficient. But how to optimize the performance is still an open question. And in this talk, we give an interesting path to address those performance optimization problems. And the most fundamental idea behind our work is building a new abstract to encode and represent the dynamic neural net structure. And this is the most important, most critical idea. With that, I conclude my talk. Yeah, thank you.
Okay, we have a bit of time for some questions for Professor Lee, Dong Lee. Yes.
Thank you. Very interesting topic. So I was wondering, can we apply the same method for inference? Do you have any insights on how to change? Does the model need to change, or maybe we can use the same representation for offloading during inference?
Yeah, thanks for the question. So this method can be utilized in inference, but we didn't apply it to inference. Instead, we applied it to training first. This is because during the inference scenario, many cases you use a batch, and you use a batch of training a batch of query samples. And if you have dynamism, quite often all of dynamism will be equally activated. So you see the point. If we have equal opportunity to activate all the model components, there is no sense to predict which component should be activated. But of course, if you feed the inference request to the model one by one, still you need to decide how the activation happens. Yeah.
Okay. Some more questions. Good chance to. Professor Lee will be presenting as well in this evening after the dinner, doing you'll have another chance to, on a slightly different topic, but that's another opportunity. Last chance, maybe? Okay, well, let's give Professor Lee another hand. Thank you so much. Okay, we're just going to take about a 5-minute break, and then we're going to be continuing with our next presentation, which is going to be online. It's Guanhua Wang from Microsoft. Has a really interesting topic ahead, so I just need a few minutes to get everything set up, so please just be patient for a couple of minutes, and we'll get the next started. we're going to be 5, but maybe I can see if I can get them a bit earlier. So what do I need to, should I unplug this while I get it? No. I could just see if there, I mean, it's only 4 minutes, but hopefully it's not I'll just go to that Zoom link, I guess. Should I open it up? Or how are you? I don't know. Oh, they have it. Okay.
Hello. Shall I start or can you hear me? Okay. Okay, cool. Okay. Hi everyone. I'm Guanhua Wang. I'm a senior researcher in DeepSpeed team at Microsoft. Today I'm going to talk about my previous research project called Zero++, which is extremely efficient collective communication for large-scale model training. This is a joint work with my colleagues at Microsoft DeepSpeed team. So the motivation here is the model size grows exponentially, as you can see on the left-hand side figure, from the BERT 340 million parameter to recent GPT and Megatron Turing model, and also to recent like Llama 3.1 model. The model size grows exponentially, like from several hundreds of million parameters to several hundreds of billion parameters. Larger model size means we can use more GPUs and need more parallelism to train a giant model. However, usually the max global batch size is fixed, such that if we use more GPUs, it means we have smaller micro batch size per GPU during the training. And it become our first problem is that communication is a huge overhead in small batch training. Here the batch means micro batch per GPU. As you can see in the middle figure here, the orange bar are the time used for the communication during one training iteration. From right to left, as we decrease microbyte size from 24 to 16 to 8, the communication time, the orange bars increase significantly from 26% up to 44%. The second problem we are countering here is the communication is a huge overhead, especially with limited internode bandwidth. As we now see that for intranode bandwidth, because we have NVLink and NVSwitch, it usually gives you like several hundred gigabytes per second. However, for cross-node InfiniBand links, it only can give you something like 100 up to 800 gigabits per second, which is like 8 times slower than the intranode bandwidth. As you can see on the right-hand side figure, once we scale a GPT model training from 64 GPU up to 384 GPUs, the teraflops per GPU decrease significantly in different internode network setting, like 8 IB, 4 IB, 2 IB, and 1 IB cases. IB here is an InfiniBand link. So Zero++ target to reduce the communication overhead in the following two cases. First is because of the small batch training. Second is on the limited internode bandwidth like Ethernet or InfiniBand. So before we dive into the Zero++ work, first I want to give a recap on the DeepSpeed Zero Optimizer. Basically, it's a very easy to use paradigm for large language model training. And it provides a memory efficient data parallel training paradigm. Basically, it mimics the data parallel training will improve the memory efficiency significantly. And for training billions or trillion parameter model, we usually use 0 stage 3. So the bottom figure here is the workflow of 0 stage 3 training of one iteration. So after we initialize the DeepSpeed engine, it will partition a model evenly on all the GPUs we use. And before we do any forward propagation, every GPU, for a particular model layer, every GPU need to do altogether, which recollect the full width of a particular layer. And after that, we do a forward compute on this specific layer. And then each GPU dump the full model width of this layer and only maintain the model weight partition initially assigned to this GPU. And during the backward, we do it again, like during the backward altogether, we recollect a specific layer's full width by using altogether, and then we do the backward compute And after that, we generate the gradient and doing a backward reduce scatter on gradient. And then we do the parameter updates. That's like a whole pipeline of training iteration in 0 stage 3. So the communication volume analysis here is like shown in those orange boxes. We have 3 collective in 1 training iteration. Assuming the model size is size m, we have forward altogether on width with size m and backward altogether on width similarly with size m. And because gradients usually equals to the number of weights, so the backward reduced scatter also has size m. So in total, we have communication volume of 3m. And how to reduce this communication volume is a big question we want to tackle. The first component in 0++ is called QWZ, which is try to reduce the forward altogether communication volume by adopting quantization technique. However, if we naively do a global quantization on the width, it will cause model divergence issue significantly. So instead of using like a naive or global quantization, we do block quantization such that within each block, it will have a specific quantization value and specific scale value. By doing this kind of block or group quantization, we can achieve 3.3x precision improvement compared with the naive implementation. And also we develop highly optimized CUDA kernels, which achieve 2.5x faster performance compared with PyTorch. And by doing this quantization from 16 bits to 8 bits on weights, we can reduce the forward altogether volume from m to 0.5 m. The second part is called HBZ module, which is to reduce backward altogether communication volume. Here we borrow a different methodology. Instead of doing quantization, here we just have a secondary model partition. Here the secondary model partition means that before that, 0.3 just partition model evenly on all the GPUs in use. However, in our secondary model partition in HBZ, we only partition this secondary model replica within each node, such that when we're doing the backward altogether, it only happens within each node. So we do not have any cross-node communication for the backward altogether. This is a trade-off between memory and communication. Basically, we use more memory because we have secondary model partition on each node, but we reduce the cross-node communication down to 0. By holding a secondary model partition within each node, we reduce the backward altogether on width from size m to 0 for cross-node communication. The third component is called QGZ, which is to reduce backward reduced scatter communication. So can we directly quantize the gradient communication? We find that by doing it naively, it will have significantly precision loss due to the reduction operation on low precision values. So instead of doing that, we develop a novel hierarchical auto method to replace the nickel reduced scatter. And we can communicate in 4 or 8 bits, but we reduce or doing the or reduce reduction in full precision, which means 16 bits. And by doing this kind of novel hierarchical auto communication, we reduce the backward reduced scatter on gradients from volume of m to 0.25 m if we use 4-bit quantization. So the methodology summary here is by breaking down like 3 different collectives. For the forward altogether, by adopting the efficient block quantization, we reduce a communication volume from size m to 0.5 m. And in backward altogether on width, by using the secondary hierarchical model partitioning, we reduce the cross-node communication volume from m to 0. And in backward reduced scatter of gradients, by adopting our novel quantized collective communication, we reduce the communication volume of gradient from m to 0.25 m. So in total, we reduce the communication volume from 3m to 0.75 m, which is a 4x communication volume reduction. Due to the time constraint, I will mainly talk about system design for the gradient communication, which is called the QGZ module. So our initial challenges for quantization gradient is first, there is no existing collective for quantized gradient communication. So we need to implement on our own for CUDA kernels and Python bindings. And the second is that one bit Adam or Lam optimizer cannot be directly applied at 0 stage 3, mainly because one bit Adam assume every GPU to have a global optimizer states. However, 0 stage 3 partition the optimizer states across all the GPUs in use. Third, directly apply quantization on the ring-based reduced scatter will have longer latency and lower precision. As you can see in this bottom figure here, we have 4 GPUs, they form a ring, and they will do the reduced scatter in the counterclockwise direction. So by conducting a ring-based reduced scatter among these 4 GPUs, the number of sequential quantization and dequantization kernel involved equal to the number of GPUs we have. And the longer of this sequential Q and D we have, the longer latency we will have and the lower data precision we will have, because the quantization and dequantization precision loss will sum up once you do it sequentially. So there are too many quantizations here. So in order to tackle this first challenge of too many quantizations, our solution is to replace the ring-based reduced scatter with our one-hop outwall collective. As you can see on the right-hand side figure, after each GPU generates its local gradient shown as those gray boxes at the top, right top, we do a one-shot quantization. Then every GPU gets the quantized gradient as the blue chunk on the right-hand side figure. And after that, we do a one-shot outwall globally across all the GPUs we use. Then we do a one-shot dequantize and reduction. After that, every GPU just gets its final correct gradient placement. By doing this, by replacing the ring-based reduced scatter, the number of sequential quantization and dequantization decrease from number of GPUs to just one in our one-hop outwall collective. The second challenge with our one-hop outwall communication is the communication volume blow up. As you can see on the left-hand side figure, if we do ring-based reduced scatter, the cross-node communication volume in total should be M, given the model size of M, and we have n GPU per node. However, in our one-hop outwall methodology shown as the middle figure here, even after each GPU do a quantization gradient, each GPU still needs to send out M/4 data cross-node. And for each machine, it means each machine needs to send out n times M/4 communication volume cross-node, which is huge compared with M. So how we solve this is we do it in a hierarchical way. So the step one is we only do intra-node outwall and reduction. Basically, after the intra-node quantization and reduction, every GPU just need to send out M/4n instead of M/4 data cross-node. And then in the second step, internode outwall, because every GPU needs to send out much less data. So in total, each node only need to send out M/4 data, which solves this communication volume blow up issue. We call it hierarchical outwall. The third challenge we encounter is the hierarchical outwall have a data misplacement issue. As you can see in this 4 GPU setting, the final correct gradient placement should be looked at the green chunks at the top. Basically, the gradient chunk of partition 1 should be located on GPU 0. Gradient chunk 2 should be located on GPU 1, so on and so forth. However, if we directly do the hierarchical outwall, after the first intranode outwall, as you can see, the GPU 1 cannot even see the gradient chunk 2 on its local memory. Similarly, on the GPU 2, it cannot see the gradient chunk 3 on its local memory, which should be its final correct data placement. And because of this issue, after internode outwall, the GPU 1 and GPU 2 get a data misplacement issue here. So in order to solve it without too much end-to-end latency involved, we do a very quick tensor slice reordering before anything happens. Basically, after each GPU generates its local gradient, like those green chunks, we do some tensor slice swapping. Here, we just swap the order of gradient chunk 2 and 3 in reverse order. And after that, we do an intranode auto. Now the GPU1, the G1, can see the gradient chunk 2 in its local buffer. Similarly, the G2 can see the gradient chunk 3 in its local buffer. And then after the second internode auto, every GPU get its correct final gradient placement. So the QGZ overall workflow look like this. Before we do any operations, we just do some tensor slice swapping within each GPU, which doesn't take much time if you implement it in kernel. And then we do intra-node quantization to either 4 bits or 8 bits. And after that, we do intra-node auto communication and do a intra-node dequantization and reduction to get the partial local gradient, reduce the gradient on each GPU. And then we do a internode quantization and the internode auto communication, internode dequantization and reduction, such that every GPU get its final correct gradient partition. We also do some systematic optimization, such as kernel fusion. For example, we fuse the tensor slice reordering with the intranode quantization, as well as we fuse the intranode dequantization, intranode reduction, and the internode quantization into a single kernel in order to reduce GPU memory I/O times, thus reduce end-to-end latency. And we also conduct the intranode and internode communication overlapping because they are working on different chunks of data. They do not have data dependency. So we can do like 2 NICO call and make them overlapped to reduce the end-to-end latency. Now comes to the evaluation. As you can see on the left-hand side table, we target on small batch size, as you can see on the left arrow. We target on every GPU only train 1 or 2K tokens. And for the low cross-node bandwidth, which is 1 IB connection column, it means the cross-node bandwidth is 100 Gbps per second. In this 1 IB connection, we can achieve up to 2.16x speed up compared with 0 baseline. And even for 8 IB cases, relatively high cross-node bandwidth, we can still achieve like 29 or 30% speed up compared with 0, which is also decent. And on the right-hand side, we also conduct the scalability performance analysis from 64 GPU up to 384 GPUs. As you can see, the left 2 figures on the right are the 1 IB connection numbers. You can see in this IB equals to 1 cases, 0 plus plus outperform 0 significantly, like 2 or 3 times. And on the rightmost 2 figures, with IB equals to 8, which means 800 gigabits per second, we still outperform the baseline maybe 10 or 20% marginally. We also conducted the validation loss experiment, and we tried 2 different models, a GPT 350 million, a small model, and a medium model like GPT 13B. In both model cases, 0 plus plus match the loss curve of the baseline. And we also integrate with some latest deep speed feature called 6-bit quantization into 0 plus plus. It also matches the baseline loss curve. We also conduct the evaluation of IRHF on the Llama 270B and the OPT30B. As you can see on left-hand side figure, in 64 GPU case, we achieve up to 2x speed up compared with 0. And when we scale up to 128 GPUs, we achieve like almost 3.3x speed up compared with 0 for Llama 70B. And on the right-hand side figure for OPT30B, in 64 GPU, we achieve 1.8x speed up, and in 128 GPU case, we achieve almost 3x speed up. At the beginning of this year, LinkedIn adopted our method, and it helped reduce over 50% of training time for production workload at LinkedIn. And we have some like a meetup there in Silicon Valley, talk about it. Yeah, so summary here is Zero++ incorporates 3 techniques like the QWZ, HPZ, QGZ to optimize the end-to-end communication during the zero training. And we have a 4x communication volume reduction compared with zero. Also compared with zero, we achieve 2.16x speed up for 384 GPU training and achieve 3.3x speed up for RLHF training. And DeepSpeed already integrated with our open source repo and serve as a next generation zero training engine. And we are looking for all kinds of collaboration and users. If you have questions or interest, please ping me with an email at the bottom. Thank you.